Jean-Michel from France. He's going to be talking on a very significant program that was done a few years ago, looking at odour emissions from liquid and solid area sources and with an intercomparison of a range of different sampling devices, which continues on the theme of the system. All yours.
Okay.
Thank you.
Thank you, Richard. So, of course, it will be less theoretical than the previous presentation of Jane. So, this work has been carried out in collaboration with two other institutes and with the cooperation also of a lot of organisms. But I will precise the frame of the study. So, the context, of course, we all know that we want to know how to measure emission from our sources, what kind of sampling device, an internal or a flow chamber, and how to control all parameters that are influent for that. We all know that, of course, we can find a lot of devices. The model from Vanessa W, for example, John explained this morning that we need, in the revision of the European standard, to have more data and more precision about sampling. And of course, we have more or less the choice to use what I call the flow chamber type of the EPA model, which is more based on isolation of one part on the surface and with a smaller flow rate inside. So it's called low flow chambers and wind tunnels with higher flows. We also all know that we have different factors that can be influenced on the emission and on the process. And of course, if you increase the temperature of the source, you will emit more compound. But for the other parameters, it's not so obvious. We just talk about wind speed that can dilute inside the wind tunnel instead of increasing the emission. And the same effect for air temperature or air humidity can also sometimes limit the transfer. So we can have different kinds of problems with these parameters, but they are easy. It's easy to measure and then to understand the global behavior of that. We have also to consider other factors, typically the atmospheric pressure, to compare if there is a difference between inside and outside the chamber. If you have radiation, solar radiation, so if your device is increasing in temperature or not. So the aim of the intercomparison, of course, was to really compare all devices that are used in France, because a lot of people are using different devices, to estimate the variation between these devices, and of course to propose a device for a French protocol that can be also proposed for the same group. So as you can see, we have a lot of participants in the standardization process in France. So we have a standardization committee, and you can see participants, so consultant agencies or big companies. And the study was supported financially by ADEME, which depends on the Ministry of Environment in France. So for that, we test, I will just present the results on test. We test on solid and liquid sources. Of course, previously, for solid source, we verified the homogeneity of the source, so we can define good location to place chambers, and of course, we verify if the odor level is sufficient or not. For odor source, for liquid source, more or less it's the same. We verify the odor level previously, but of course we do not check all the surface, or more considered as homogeneous in the middle, but without strong verification previously. So we tested all different kinds of devices, and in fact, the devices is the only parameter. I mean, all bags were purchased from the same batch and the main manufacturer. and of course it was the same source, and it was also, the analysis is carried out, or what was carried out by the same lab, one accredited lab for samples from a liquid source, and another one for samples from solid source. So strictly with only one parameter, the sampling device. The experiments were carried out during 2 days, so 3 sampling each day, and in fact we had 1 sample in the morning, 1 in midday, and 1 in the afternoon for both solid and liquid sources. So you obtain in series S1 to S3 and 1 to L3. So after each society or company used its own device with its own protocol, of course we just start at the same time. So you can see the different chambers on solid. If we want to have more precision, we can say that there is 2 main types. In fact, chambers from 1 to 5 with high flow or higher flow, and with 6 to 8 more based on isolation with low flow. So if we look at the results about odor concentration, we can see that of course it's not so surprising. We have lower concentration here, so we have a difference between low flow and high flow. So it can be interesting to note, but globally the difference is not so hard. But we want to calculate an odor flow, and when you introduce the flow, of course it's very different. So I just take the low flow chambers here, and you can see that even with this 3 you have quite a big difference. 2 are more or less the same, but 1 is very different. If you consider now chambers with high flow, it's really totally different. As you can see, typically the 2 chambers that are really wind tunnel type, this one and this one, with the highest wind velocity, of course, give higher results in terms of odor flow. And as you can see, of course, the difference in terms of you cannot imagine the difference. It's better to do not calculate. So we cannot accept to work with this kind of devices because it's too huge in terms of results. So if we eliminate the 2 wind tunnels and we keep the other high flows, it's more restrictive in terms of results. But even if you have, quite still big differences. If you compare with low flow chambers, you can see that you are not in the same range of value. So you have no recovery between the 2 kinds of devices. So that's typically the main problem. Of course, you have the discussion, but typically the 2 types of device directly give results in different ways. So for that, for this results on solid source, of course the tendency is not the same. For each chamber, we have still a stable behavior, but we cannot compare really the result with another one. And as we all know, of course, the main problem of wind tunnels or very dynamic chambers is that you can dilute a lot. Sometimes your sample, but because your odor flow is a multiplication of the flow and the concentration, you can increase with very high values your odor flow in some cases. So the compromise must be chosen. I will give very quickly the results on the liquid surface. So in this case, 9 chambers. So 3 chambers with low flows and 6 others with high flows. If we look at the results, so now, of course, it's the odor concentration. As you can see, in that case, it's very different. You have a factor of 10, more or less, but at least a factor of 10 between high flow and low flow chambers. So it dilutes a lot the emission in that case comparatively to this one. If now you consider the odor flow, of course, you change the tendency because you obtain high values in this case. But as you can note, of course, you have some data that are missing here. It was the case just previously. It was due to the fact that if the wind speed inside the wind tunnel is too high, of course, you dilute your emission, and you are under the limit of quantification for olfactometry. So it was fixed at 50 odor unit in that case. So we can say that we have really to limit the wind velocity and the flow in dynamic chambers. It's typically shown here. We compare 4 of dynamic devices. We can see here the odor concentration in blue. So it's not so different, about between 100 and 200 odor unit per cubic meter. But these 4 chambers are very different flow rate, from 12 to 300 liter per minute. And of course, because you are quite constant with your concentration that you multiply by your flow rate, of course, your odor flow is increasing a lot. So, where is the truth? If you have to calculate an impact after, do you have to consider your odor flow something like that? Less than around 5,000, or maybe 10 times or more. So I think we are ready to fix a limitation somewhere here, and also due to problems due to aerodynamic inside as a chain. Just speak about that previously. So for the liquid source, the problem is really with high flow in these chambers, and even if theoretically the high flow is made to simulate the external condition, we cannot reproduce all external condition in a small box like that, so we have to limit, and of course to say, okay, we push as we can, maybe 1 meter per second, 1.5, but probably no more, of course, depending on the design of the chamber. So we are really to find some limits and to find a way to estimate if the chamber is acceptable or not for the standard. John said this morning that, of course, we have to fix a protocol for the emission rate, and it's typically that way that we can say, okay, we can fix a limit. We obtain the emission in a range with a pure compound in one case, and if it's in this range, it's okay. If not, we can reject the sampling device. So, for that, the conclusion of this study, of course, we confirm that we have a large variety of results due to the variety of devices. The results are totally dependent on the devices, of course. We have probably to select device by the application, so of course, solid and liquid, maybe it's not the same. And more important, I think we can use 2 kinds of device for low emissions, for more an isolation chamber like flux chamber like EDA model, or for high concentrated source like a wind tunnel. you have, of course, to limit the conditions of use of this wind channel, and also for flood channel. And of course, the perspective is to use all this data and all the experts on the subject to select the better compromise. It's sure that it just can be a compromise and not the real device for estimating or for measuring the real emission. And of course, one perspective is, of course, to integrate all these aspects in the revision and sampling part of the new standard Guilleman 13725. Thank you for your attention.
You had your chance. Lara.
I'm sorry. But I wanted just to make a comment which also links to the presentation of Jenny before, I think, which is that maybe in the future perspectives we should add also to, let's say, study a little bit better what happens when we vary the wind speed over the surface that is studied, because it's not new that there is a dependence of the flow rate from the emission rate of the mass transfer coefficient due to the air velocity that is over the surface. So for liquids, it's rather assumed that it's like the square root, the proportionality with the square root of the velocity. For solids, it's not so evident what happens, and so this would help maybe to compare, to better compare the results of different guides. I think this is a very interesting step towards standardization of some kind of standardization of sampling equipment.
Yes, I totally agree with you. I think we have two ways, of course. We have to improve the knowledge about these emissions, and typically to do the link with the model for emission. And we have also some need to have something very practical for EJ to have a value, even if it's not the real one, but to fix limits and to be sure that we do not spread the results only with the sampling devices, because actually, of course, you have typically in Germany the VDI guideline 3880 that fixes one sampling device, so it's easy to compare. In France, with this discussion, you can have a result from 1 to 1,000 easily, and so you don't know whether to. So at least we can fix something, even if we have to improve our knowledge about the emission.
Okay, thank you.
Yeah.